Here we're going to talk a little bit about the development of the periodic table. So originally, 1864, there was an English chemist, John Newlands. He noticed that when elements were arranged in order of atomic mass, every eighth element had similar properties. So this was one of the first sorts of ideas leading to that elements could be arranged in a certain order. He referred to this particular relationship as the law of octaves. Every eighth element, this would be occurring. This law really didn't work out that well. Once you hit calcium, everything fell apart. So it wasn't accepted by the scientific community at the time, even though he was definitely onto something. So this is 1864, where more famously, 1869, you had the Russian chemist following him up, Mendeley. And also at the same time, independently, a German chemist proposed a much more extensive idea around this periodicity in the elements, that there is some sort of regular interval in which you would get elements that acted quite similarly. Mendeley ordered the elements also based on the atomic mass, which led to inconsistencies. We know that that's not how we use the periodic table currently. It's not based on the atomic mass, but rather number of protons, right? The atomic number. One of the examples where this didn't work out well, for example, argon and potassium would switch places on the periodic table the way Mendeley had written it, if they were ordered by their atomic masses, which again, remember, is based on the particular isotope that you're referring to and the natural abundance of those isotopes. If this were the case, potassium would be grouped with neon and helium, which doesn't make much sense, and argon would be grouped with sodium and lithium, which again doesn't make sense. So there were still some flaws with Mendeley and this idea of periodicity based on atomic mass, but he was able to predict certain elements before they were, including their properties, before they were discovered, and that was really why he was credited much more than the others with this development of the periodicity and therefore essentially the periodic table. This key to periodicity turns out to be the atomic number instead of the atomic mass, which we're all familiar with. We know that the modern periodic tables order these elements by the atomic number, i.e. the number of protons. Elements in a column of a modern periodic table have very similar chemical properties. We already are somewhat familiar with this because we know certain columns tend to have ions of a particular charge. So this is because of their similar chemical properties. So an example problem here would be, what elements would you expect to exhibit properties most similar to those of chlorine? So because the elements in the group tend to have similar properties, you should look at the groups in that same, look at the elements in that same group as chlorine. Chlorine's a member of group 7A. So you'd look at the other elements in that group. Take a look at chlorine here, and fluorine, bromine, and iodine are also in that group. And so those should be some that would have properties most similar to chlorine. So fairly straightforward.